This is an introduction to systems of linear inequalities. As part of this intro, I would like you first, please, to graph this equation. Sketch the graph of this equation, and it is x plus y is less than 3. So please take a moment to graph this linear inequality. So in order to graph x plus y is less than 3, we'll need to take x plus y is less than 3 and put it into what format? Who knows? Somebody raise your hand. All right, Tiaja?
Slope intercept.
Yes. You put in slope intercept form, which means you get y by itself. And in order to do that for this problem, okay, you need to subtract x from both sides. And you end up with y is less than negative x plus 3. In order to graph it, you then look at that y-intercept. What is the y-intercept of this equation? Somebody raise your hand and share with us. Yes?
1.
The y-intercept is 1? Looking at this problem? Yes. It's actually 3. Remember, b is the thing being added or subtracted from x. Our slope-intercept is 3. So I'm going to go ahead and take my pen. I'll use a different color and mark off 3. Okay. Now, the slope then of this equation is what, Sheetal?
-1.
It's -1. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1. Now, the big difference then between an equal sign and an inequality is that y is less than negative x plus 3, not equal to. So am I going to use a solid line or a dashed line? It's going to be dashed. When would I use a solid line with an inequality? Tiaja?
If it was less than or equal to.
If it's less than or equal to. In this case, it's just less than. So I'm going to go ahead and sketch a dashed line with arrowheads on it. Last but not least, y is less than negative x plus 3. Y is less than that line. And we'll need to do some shading here in order to indicate that it is less than. What do you suppose we're going to do in order to indicate that it's less than? Yes?
We plug in 0.
Okay. Plug in 0, 0, and then find out if it's
True or not.
if it's true or not. All right, so let's go ahead and try that out. We have 0 is less than 0 plus 3. We end up with 0 is less than 3. Is that a true statement? Is 0 less than 3? It is. If it's true, then we shade where the 0, 0 is. In other words, we're shading below the line. And you might remember that trick that we said, if it's y is less than a bunch of stuff, we shade below the line. If it's y is greater than a bunch of stuff, we shade above the line. All right, very good. All right, so now take a moment, please, to graph x plus 4y is greater than or equal to 0. So, based off of getting this inequality into slope-intercept form, we get y is greater than or equal to negative 1/4 x. We see that the y-intercept is 0. We go down 1, and we move over 4. We shade above. We plugged in 1, 1. We have 5 is greater than or equal to 0. It's a true statement, and therefore we did shade appropriately. So we'll regraph that first equation, and what we had gotten for x, what we had gotten for x plus y, is less than 3. We had said our y-intercept is at 3, and we said our slope is down 1 and over 1, down 1 and over 1, down 1 and over 1. I'm going to take my line maker tool, go through those points. Okay, there's the first one. And actually I used a solid line, so I need to undo that and use a dashed line. And then we said, well, we need this to be a true statement, and we shaded below the line. That looks like this. Okay, so that's what we did for our first example. Now we're going to graph that second example on the same xy plane, and that second example was x plus 4y is less than x plus 4y is actually, greater than or equal to 0. And for that one, we said the y-intercept was at 0, and we had to go down 1 and over 4, down 1 and over 4. And we said we're going to use a solid line for that one because it's greater than or equal to Noah? You okay? Okay. Trying to get this line to line up. One, 2, 3, 4. It's not wanting to grab that spot. Alright, well, we'll just do the best we can. It looks something like that. It's a solid line. And where did we say we needed to shade this one? We want to shade it above. So we're going to go ahead and shade above the line. And I use different colors here. And we notice we've got 4 different sections of our graph. We have this section down here where it's just yellow. We have this section over here where there's no shading at all, this little piece of pie. We see this section above where there's nothing but red. And in this section, we see both yellow and red. You guys see that? So there's 4 different sections that appear. The solution to this system of equations is where those 2 areas of shading intersect. Okay, where it's yellow and red. Also note, if it's on the solid line and bordering that double shaded section, that's also a solution. But if it's on the dotted line, it's not a solution. So it gets very technical, and you'll have to use your full understanding of a linear inequality in order to figure that out.